Good evening, everyone. Thanks for joining us. So my name's Eran and I'm here with an interagency team of scientists and emergency managers to talk to you about what's new this year for the Mendenhall outburst floods in our monitoring program and our forecasting program. I'm here with Tom Mattice with CBJ, Jamie Pierce with the USGS, and Eran with UAS. And tonight we're going to kind of go through some updates for what happened over the past fall, winter, improvements, and we want this to be interactive, so we're going to kind of go through these slides pretty quickly, but we want to get more to the question and answer portion of the talk. But USGS is going to give an update, UAS will give an update, and then CBJ, Emergency Management, will give what their messaging is for planning for these outburst floods, and then myself with the weather service will give what changes, a new paradigm for our river forecasts, along with how to find our inundation maps and the new monitoring page with new equipment from the USGS, which Jamie will talk about. So first, just going to get us oriented of what we're talking about here. Suicide Basin is the side glacier off of the Mendenhall Glacier. Suicide Glacier is detached to form this basin, and then it holds water every year, and then it drains down the Mendenhall River into lake into river. This is kind of what it looks like today. You can see how Suicide Glacier has detached from the basin, the main trunk of the glacier, the Mendenhall. And we'll have Jamie actually tell us about what's new with the USGS this year. So kind of just quickly kind of transition to that.
I'm going to try to dim my light so that I don't think it would be easier.
So yeah, Jamie, here's the USGS.
Okay, well, hello everybody. My name is Jamie Pierce with the USGS. I'm a technician. Small office here in Juneau. We've been here for a long time, and during that time I've helped create and start the monitoring program up in the basin. Real quick, just some quick, without some critical people on this project, we wouldn't have been able to move this along.
Could you please speak into the mic more?
First and foremost,
You can pull it out of there so you, and then
pull
just
it over
hold
a little
it.
bit. Okay. Can everyone hear me okay?
Yeah.
Okay, so first and foremost, the city and Borough of Juneau and Tom Mattice, and as well as Jeff Conway, the wild director at the USGS, and then Randy Host here in Juneau, our office chief and hydrologist, and then all the other folks in our office with helping me along with this program. So to start with, the first thing, we are USGS all around Alaska. We are not only in the basin, we're also down on lower Mendenhall River, but throughout Alaska we do surface water, we do groundwater, we do water chemistry, we do a lot of things. So water science is really within our purview, and it's what we do. We like to believe we do it really pretty well. So Suicide Basin really does fall within the scope of the work that we do at the USGS, which is measuring water. In the case of Suicide Basin, I'll get into those details shortly, but it's very much within the scope of work that we do here. Our jobs are a little bit of everything. We're a little bit surveyors, engineers, hydrologists, technicians, plumbers, carpenters. We kind of wear a lot of hats. When we're in the field, it's a lot of wet field work. It's not always dangerous. It's oftentimes fun. Because of where we do live, we are dependent on a lot of aircraft. Our office is very small. Mendenhall is one of the few gauges that we actually have that we can actually drive to. Most of the gauges that we monitor throughout Southeast Alaska, the areas that we're responsible for, we have to fly to, including Suicide Basin. It is a challenging spot to get to, as everyone in this room knows. So that's a little bit about us. So just the spacebar to move forward, right? So typically what we're doing is, for Mendenhall in particular, many of you have seen us downstream on the back loop bridge, maybe you've seen us measuring. We go after the measurements. We want to know how much water is in there. We want to know how fast it is, how wide it is. Basically where it's wet in the channel, we want to know what that is. So we're at the gauge, we're at the river quite often, about every 4 to 6 weeks on average. And throughout the year, we're measuring, because what we really do, one of the big things we do is we build what we call a rating curve to be able to publish the discharge, the amount of water that is coming out. And we do that by getting stage information. I'm not going to get into great detail on that. But the discharge here on the bottom is this curve here. Just giving me our gauge height here. And then just a quick illustration of what we use to develop our rating curves for our stage discharge work. So we're down lower Mendenhall, and then of course up in Suicide, but we're here to talk about Suicide Basin, and we know where it is. So I'm going to zoom in real quickly and just kind of get right down to the nitty-gritty of where we are working. And just real quickly, backing up, when I first started this program, I had kind of a unique set of skills that allowed me to get in here with those folks that are on the team. And we developed this program, and it's not the easiest place to get in and out of. So we had to use some creativity to do it. Luckily, the USGS has been doing this for a while. We've monitored other glacier lake outburst floods around the state, and so we've developed some techniques at the survey that are they're good. And by that, I'll show some illustrations here in a second, but it allowed me to kind of bring some of those skills learned and bring them into the basin to get some meaningful data, which is, I believe, we've been able to do. Not always. It's not always been rainbows and roses. Okay, so let's see. Take this off. Okay, so everyone can hear me. Okay, so here's the basin. So the last picture you just saw was basically, so to the right is the glacier dam. Where we are working at is basically the face right in front of you, okay? The basin fills up, and the first place I'll start with is where we have predominantly most of our instrumentation, which is at the very top. I don't have a laser pointer, but if you look at the very top, you see the arrows. There's a couple of white. That's where our data logger and all the telemetry and our gauge box that we call resides. That's this picture right here, okay? This instrument right here is a laser. It's just a very high precision, they say military grade, but it is. It can shoot a very long distance at a very accurate rate, and it shoots a continuous set of beams, and it averages over a few seconds, and then it'll save that meaningful number every 15 minutes. We're collecting data 24/7, every 15 minutes, and it's shooting it down, and we work out the geometry to be able to get the vertical differencing of that. We also have satellite cameras, a little mini weather station. We have a tipping bucket. The weather information, while it may not sound important, it actually is, because precipitation, all these things, we kind of add all that stuff together to get our meaningful information. So there's just an image of our data logger. And then the middle picture is just me down working the rope, getting ready to pin in some other sensors that I'll show you here in a second. It requires some rope work to go down. And then at the very bottom, I have some backup pressure transducers, which is literally just pressure transducers. It measures the head pressure above these. And so what we'll do is we'll get a reference elevation of these as we do with a lot of things at the USGS, we get reference elevations against other known datums. So we tie everything into, and most of this work, actually all this work is for those that matter, it's on live. I think we're on the vertical 88 datum for this one. Randy and I set this up, so it'll be easy to be able to convert that in other studies and stuff. So that's basically that. So there's the laser, camera, meteorological stuff. Not much, just not the easiest place to get it done. Okay. So for the first few years, we used these steel 1-inch braided galvanized cables right here. We pin them, we use those throughout the state of Alaska. We'll pin them to banks and down into the channel with big rebar so that high energy doesn't pull the cable out. So we're able to actually continuously measure with an over-hardened 1-inch cable. These are 5/8 inch bolts. And so what happened is I built it, and it looked all nice, pinned it up, and everything was working really good. Randy and I had spent we did a number of trips in and out of there working ourselves to get this. And so what happened is the first year, and there a couple other after there would fill in, the ice of course floats, and then when it goes down, it migrated, and as it came down, it sheared. And I had these really strengthened. Really, what I thought were really, I didn't think that would happen, and it goes to show you the power of it. So, so what we're doing is we are actually going to do that again, but we're not going to go down as deep in the basin this year. Okay, so the laser development came when we put the KPSI in those cables. They weren't quite working out. So the laser, we came up with the laser idea. We tested it, ran it. I came up with kind of a creative way. I just filled a bucket, popped a hole in the bottom. We did our differencing. It just measured the floating wood as it went down. It worked real good. We went to the basin, turned it on. Everything looked real good. One kind of interesting thing, this is 2017 with the proximity of the ice. It's much closer. It doesn't really look like it. This first measurement out of when we first turned it on without doing our calculations, okay, it was about 210 feet. This one was 765 feet difference, okay? I ran them plus or minus 2 weeks of install, okay, of each other, okay? A little over 200, so that's down distance. Same elevation, same. So just kind of an interesting point there. So as I mentioned, we truth all that with static surveys. Static surveys we run, it's a global navigation system. We let it run at the high precision, it basically just high precision. We let it run for a long time, and we will get the elevation of the water so that we know what that is. And then what we'll do is we'll put in those corrections in the time series for our records. So what we would put out to the public, so what you would see would be a working time series that we work. This is kind of our world. This is Aquarius. We work our time series in this. These red and blue lines represent those each 15 minutes of data created over time. This axis is time, and the y-axis on the left there is we call it the net ice surface. So the surface of the glacier, surface of Suicide Basin is ice and water mixed. So that's what that is. It's going to paint a little bit because there's floating ice and water, but just forget about that. We're not worried about that, but you can see the resolution dropping, and then when we see an outburst, we know that outburst flood has a very unique ascending limb and descending limb. The ascending limb is very steep usually, as you can see here, and then a rapid drop off. And the laser worked very nicely tracking that. over time, and then the continued rise. So that's, excuse me, and I didn't mention, this is discharge downstream, so this is discharge, this is our mendenhall gauge. And that gauge site is at the lake. Our control for that is the lake, actually. Okay. So this is what a standard KPSI hydrograph looks like that we look. So this is non-laser. We like these because the resolution is very, very good. So we will also have this in. We're going with the redundancy this year, recognizing the seriousness of the situation. We decided to we're going to throw some instrumentation at this. So we're going to also have a KPSI. So another 1-inch cable is sitting in our shop, waiting for install, just waiting for weather, and really things to just dry up there before we get up there and pin it. But this is what that will yield. This is important because the Weather Service we do with our satellite cameras, Eran will probably touch on this, we do some pixel differencing. We grayscale, we take a sliver of a satellite image and we count those pixels and we difference that over time. So it's a very useful way, but you could say we truth it against this, okay, and the laser. And we're going to use this to truth against the other one as well. So, yeah. The other thing I just want to point out in this is, we talk about the referencing. We like to make sure that data is right and meaningful. Well, this is water temperature. It's glacier water at about 0.1 degrees, 0.01. It's very cold water, 0 degrees, 0.1 Celsius. Here's our temperature. On that axis, you can see so here you see the diurnal cycle of temperatures, and then all of a sudden she goes 0. So it hit water here. This is from those lower pressure transducers that I showed you. So that's kind of a neat way of also saying, well, yeah, it's underwater now. Okay, so this is what we will have from our satellite cameras this year. This is new. Before we just had the image on the right. Now we'll be stitching oblique, so we'll be able to see. And actually, this won't be the final image you'll see. We will try and feed this to the general public this year. These are slightly out of focus. We have a new camera this year, higher resolution and Iridium network. We're going to be updating these on a frequency of about hourly. So, and we're going to be giving this, so this will be on your website and as well as on our website for surveys. So, this is, of course, the glacier, but this is not the final image. The final one will have much more of the damming front, which is the manhole over here. Okay, moving on to that. So really, that's it. So just from our standpoint, we're going to have a laser. We'll have our pressure transducer, which the KPSI will serve two purposes. One, to constrain the laser, and then we'll have a secondary. All our meteorological parameters, precip, air temp, baro, all that, and then the 2 oblique satellite images, and then we're looking to transmit the data out of the basin about every 30 minutes. So a much higher resolution. Normal, it may not sound like a big deal. Normal is about an hour. We want it because we all know the anxiety when the basin is filling and it's not released yet when it starts. And we want to know the second it starts by the second it drops. So we see the drop not only in the sensors, but in the images and so on and so forth. So we feel like we have enough in our favor now to be able to very confidently be able to do that as well. So that's it from the USGS.
All right, well, I'm going to keep this pretty brief and kind of zoom out from some of the details. But one thing I do want to mention, so on the UAS side, we're doing a lot of the kind of research support that's providing information that helps the Weather Service make their forecasts. One thing I will mention, we have a new postdoc who joined us just today, who's here actually, David Polshansky. And he is going to be working with us all summer and sort of dedicated to this project. So that's going to be a huge advantage for us in terms of moving forward. And what I want to talk to you about briefly is just some of the research initiatives that we have ongoing and also some things that we're trying to start up to kind of look a little bit into the future. So the first thing I'll mention is that one of the things we've been doing for years now is a drone mapping program where we use a drone to take visible images overlapping about 1,200 images. And so because the drone has very accurate GPS, you can stitch all those images together into one, what's called an ortho image of the whole basin. And then from that, you can create a digital elevation model, right? So it's a digital topographic map. This is really useful because we can go right before the flood when it's pretty full, the water level is high, and then we can go and we can map it again right after the flood. And that one where you see that sort of like cavernous hollowed out on the bottom there on the left, that was right after the flood last year. And you can also see a little bit in that picture up there, one of the things that was very kind of stunning when you went up there last year is how far down the whole thing had collapsed after the flood had drained, and that was something that we hadn't seen before. So we were able to map it, and by taking the pre-flood and post-flood image, you can just difference the two because they're both models of elevation, and you can use that to calculate the approximate volume, right? And that's a super useful piece of information because now we know sort of more what the bottom of the basin is. And so for any given water level that we have with the sensors that Jamie put in, the Weather Service can calculate the volume of water that's being stored at that time. And as Eran will talk to you about, the trick is knowing how much of that water is going to come out. But obviously what we saw last year is a lot more came out than what we've seen in the past. So we'll continue the drone mapping program this year. We're also trying to think more generally about how this is going to evolve because these types of ice-dammed, ice-marginal lakes tend to be flood hazards that last on the order of some decades, maybe 30, 40, 50 years. And so we have a bunch of competing processes going on right here because people always ask, well, is it going to get bigger over time or is it going to get smaller over time? And so the answer to that is, to answer that question accurately, we need to be able to quantify how these competing processes are interacting with each other as we move forward. And I'll just mention a couple. One is that the basin's full of icebergs, right? And so if you had a cup of water and it was full of ice cubes and you poked a hole in the bottom, there wouldn't be that much liquid water came out, right? If you melted all the ice cubes and then you poked a hole in the bottom, you'd get a lot more water out. And so for a given water level in the basin, the more ice that melts, the larger volume of liquid water that could be released. So as the icebergs melt, that would lead us toward a bigger flood. At the same time, the main glacier, which is the dam, is thinning at 5-6 meters per year. So the dam itself is getting lower. That ledge where Jamie showed you where we used to work, the first year, or one of the early years, maybe 2014 when we went up there, the water was above that ledge. We had to climb up above it just to do anything at all. It can never get up there again because the dam is too low. And every year it's getting lower. So that would tell us, well, the flood should get smaller in the future. Additionally, the basin appears to be expanding out into the main glacier. There's actually a calving face there because the basin itself is over deepened, so the main glacier is sending ice down into the basin, which is then calving off. So the more icebergs that calve off and melt, the more the basin could potentially expand out into the main glacier. So in other words, it's complicated. There's a bunch of competing processes, and then ultimately, again, as Eran will talk about, you got to figure out the drainage volume. And so we're also trying to start a project where we're kind of modeling this going forward on more decadal timescales. And the basic thing that we need to think about is, well, what's going to happen with the glacier in the future? How rapidly is the glacier retreating? And so we did a modeling exercise for the Forest Service in thinking about their planning at the visitor center, and so we came up with some different scenarios, rates at which the Mendenhall Glacier will retreat in the future. So on the left was kind of the low retreat rate scenario, and then on the right is the high retreat rate scenario. If you look on the left, you'd say, oh, in 2050, the ice dam will still be in place, which is showing with the red arrow there. If you look at the high retreat rate scenario, if you look at 2050, it's pulled back. There's not even going to be a dam there, so there can't be a flood anymore. Eventually, the flood will disappear when the glacier retreats back far enough. So we're trying to think about some ways to model and be able to understand both how the processes that influence the size of the flood will change in the future, and also how the glacier will change in the future, and ultimately sort of set the time scale over which we're dealing with this hazard in Juneau. All right, so I'll stop there and I'll turn it over to Tom Mattice.
Good evening. So I guess the one thing to take away from this is things are still continuing on, and we're probably still going to see floods in the future. And we need people to have thought about that personally. We're going to talk about the maps that we have for inundation areas here in a little bit. It's important if you live in those areas that you have a plan, a personal plan. What are you going to do if it floods? Basically, in modeling that we conducted in 2014 and 16, everything left of Riverside Drive has the ability to flood in a catastrophic event. This year was near 15 feet. We've modeled it up to 16 feet, and we're going to be building new models even beyond that. But basically, if you live left of Riverside Drive, you should think about what you're going to do when it floods. So everybody needs to have a personal plan. Where are you going to go? What are you going to do? Do you have a go bag at your house? Do you have the clothes you need for the night? Do you have important documents? I know I lived in an area that flooded. I know that at 10 o'clock at night, I left the city's emergency operations center, and I was gutting my garage, moving stuff up onto shelves and moving stuff into my house. And if I had done that 2 days before, I wouldn't have dropped my kitchen sink on my thumb and had to get 8 stitches. So if I had a plan, I would have done a little better, but I was busy taking care of you guys all day. But you gotta have a plan. This year, my garage will be a little cleaner when the flood comes, and I'll have stuff up off the floors, and I'll have my go kit ready so I can not have to kayak to my house. I'll be able to drive to a friend's house and spend the night. And then when it comes to being informed, CBJ is doing a few things to kind of prepare ahead of time for this. We're developing a series of PSAs. We're developing an action plan where we talk about roads that will be closed and things that we already know ahead of time. We are working towards getting IPAWS, which is the Integrated Public Alert and Warning System. It's a federal system where we can locally trigger the emergency alert system and send messages directly to your cell phones. CBJ also has a new platform that's coming online here very shortly that you'll see in PSAs called Civic Ready. Civic Ready allows you to go into the CBJ page. You click onto this website, you subscribe, you tell them, I want phone calls, I want text messages, I want to know about the floods, I want to know about avalanches, I want to know about public meetings, I want to know about the Public Works Department. So you can click on different things that you want additional messaging from CBJ, and once you subscribe to those systems, you'll be internalized into that system. For large-scale emergencies, we'll definitely use the IPAWS system, but for smaller events and for warnings and for things that are a little less important, where we don't want to interrupt Monday Night Football, we'll be using Civic Ready. So be looking for PSAs coming out on the Civic Ready platform, and if you're interested in more information on the floods, go into those pages and register so that you get that information.
Thanks, Tom. And with that being informed is listen to hear what the National Weather Service has to say. And so we take all the information that Jamie and the USGS is able to provide, all the information and knowledge that the university and Eran's group of folks are able to provide, like Jason almost said also. But there's still a lot of unknowns, a lot of uncertainty. And there's a vast amount, like Eran was saying. But there's a lot of information that we're able to glean, like Eran was saying, within the differences between those drone surveys. We can see how much water is actually being held in the basin. And so with that information, we have an expanded elevation curve. So what you're seeing here down the bottom is how much water volume on the bottom axis, and then on the y-axis on the top is the elevation, or from what Jamie's KPSI pressure reducer could tell us, or what the camera can tell us, the elevation of that water. Then Webster's can take a look at that water level and find out how much water is, the water level, and find out how much storage is in there. We're able to do that from these drone surveys. But as we've all seen before, well, last year was something that we didn't see before, where all of the water, most of the water came out all at one time. And so, unfortunately, there's not really a confident way to say the size of this release. Is it going to be a full release? Is it going to be a half, 3/4, or a certain percentage? That is the rub. That's our work. That's what we're trying to get at. So, with that uncertainty, you know, last year produced this type of flood. So what you're seeing here, the red circle, is where last year's flood stacked up along historical crest flows from the Mendenhall going all the way back to the 70s and 60s. But that red line there on the graph shows when these outburst floods started. And you can see a lot of the upper ends of the floods on the Mendenhall River has started after these outburst floods. And then, of course, the latest one that we saw last year was well outside the range of possibilities that we've seen in the past. And looking back even further on other outburst floods, you can see that this is from the Juneau River on the Kenai Peninsula, going all the way back to the 50s, where the graph on the left is showing the, again, the size of these floods, how much water came out through this life cycle. The one on the right is showing how much water was actually in the basin at that time. And so you can see that these dots don't really all line up. So essentially, we don't really know within our history of Suicide Basin where we lie within the historical record. So again, here's what happened last year. Here's 2023. And the other shades that you're seeing, so you're seeing timing on the bottom axis and then peak discharge on the y-axis. And you can see that something's different here between everything else. The gray is pretty much what has happened over the last, since 2016. And they kind of really stay right around the same area. They don't really venture too far outside of the norm compared to then last year was so much more. Because all these other ones were all partial releases. Except for this one that last year was pretty much what we've seen, the only largest full basin release that we could measure so far. And so this year with the National Weather Service, what we're doing now is that we're going to have to represent every single outburst flood as a full basin release for planning purposes. And so that's not a full, like, it depends on how much water's in there, right? So it's not always a full basin. So like what this scenario here would show you, if the water was released at a very high level, 400 meters, this is what the outburst flood could look like if all the water released from the basin. Now, 1 out of 6 out of the last 8 years has seen this type of outburst flood, like we saw last year. But we get this information of how much water's in there, or how much water could be in there from the gauges from the USGS. So we have an idea of how much water's in there. The problem is we don't know how much will come out at one time. So being able to plan appropriately is giving us the worst case scenario for the amount of volume of water that's in there. Most of the time, it won't reach this maximum value. Most of the time, like you're saying, like 6 out of 8 times, I mean 1 out of 6 of the last 8 years have only seen this maximum of water releasing at a single time. This is what it would look like today. If we were going to release all the water that's currently in the basin, you can see that right now from the camera images that USGS has. This is what a full release would look like if all the water came out. We're able to model, knowing that volume, of what the values would be. And so this yellow line, this is action stage. This is like bank full. And then you have your minor flood stage, moderate flood stage, and then see that purple line all the way up there? That's where we were last year. So currently, we're really, really low from where we were last year. This time last year, we were 30 meters higher in ice elevation, water elevation, than we are right now. Very cool spring so far, not a lot of melt. So with a lot of the new equipment that the USGS is being able to put up for us, we're able to make some modifications to our monitoring page. So you can get into the monitoring page right here, the address, and some of the improvements is some of the let's see, the controls on the time lapse. So now you can actually go back and forth. You're not stuck on a single time frame. You can step back and forth. We're going to have the pressure transducer on there. So you're going to see how much water elevation is in the basin when Jamie gets that pressure transducer installed. And then once we get that second camera up and running, and we can stitch it, you're going to have 2 camera images right down there in the bottom right where you can actually see that wide angle view of the face of the glacier and then also a stitched image. And then there's something else that Tom was talking about was these flood inundation maps. And so we have a set of flood inundation maps that were configured back in after 2016's record flood. And our webpage went through a little upgrade this year, and so it was a little bit different way of getting to these inundation maps. I just want to kind of walk you guys through how to get them. So there you go to this water page, and I'm going to walk us through this here in a second. But you zoom into the Juneau area, and then you click on the Mendenhall gauge there, and then you're going to scroll down to where it says map gauge area, and you say activate thin, and thin is flood inundation maps. And if you activate that thin maps, you get the flood inundation maps that come up as a GIS layer. And then you can scroll over on the left-hand side to what level you're getting at, and then you can see if your home or your area is going to get inundated. You can zoom in, it's very interactive. We are looking to update these maps, as Tom was mentioning, but this is a fairly good first guess of what you guys can plan on if, from a forecast standpoint that we may issue, of what impacts or inundation may happen at your location. And another thing, when we do see any type of release or any type of activity in the basin from the cameras, from the pressure transducer, the first type of product that the Western is going to put out is typically, if a flooding situation would be like a flood watch, but because of this particular situation and this event, we're going to be just going with a weather statement, a special weather statement, say, hey, there's activity in the basin, we're monitoring, let's check back for updates, and then we're pretty much, we just want to verify that the event has started. And then we were going to go to whatever flood advisory or flood warning, which you'll be able to access from this webpage. So quickly, I'm just going to go and just do a run through of how to get to these inundation maps, and then a quick little run through of just the monitoring page. So when you come to water.noaa.gov/Juneau, you can zoom into the Juneau area, and you can select over here, you'll see Mendenhall Lake. You select here, then you get over here, you want to come to a full page zoom. And then again, here's the real-time information from the USGS, the forecast from the National Weather Service. Further down, you have flood impact information. So if you zoom out here, you can see what impacts at what levels that we saw. These have gotten updated since last year, since everything that we learned, boy, was getting inundated from those high levels. We scroll further down to this gauge information page. Come right here to the activate thin gauge, and then this is where you get to see all of our cool maps. And there's a couple different ways. You can hover over a certain level. So this is 13 feet. If we zoom down further down to Riverside Drive, you can see not much flooding except for along here near View Drive and back here along closer to the lake. But there's another feature where you can actually click on, and then you can just have a flat map. So this is all the areas that will have major flooding. Or you want to see what's that moderate flooding. Click here, and then that overlays everything that would be inundated at moderate flood level. Then also from this page, you can get to the monitor page right here. Right from the page, you get to the monitoring page. You go from here. This is the new monitoring page. Here's a nice link to this talk tonight. And we update this as soon as we get information from the basin. We usually update this with the current information. If Jamie goes up there or Eran goes up there and has a site report, we'll post up here and what information they can glean of what's happening within the basin. There's links to the inundation maps. There's a really great story map that UAS put together, and then here's all the different maps and imagery. And then like Jamie was saying, the difference in this map right here, this shows the difference between those images, so you can see if the water's going up or going down. And here's where all the other locations for the new information. So, back to this. I think it's time for our questions and answers and questions for all of us. So here's some key points to go over. Tom, you want to?
Yeah. So you can see, we're really fortunate to have great partners. I mean, USGS and University and the National Weather Service, so many different agencies are coming together to make this happen. It's really amazing. CBJ wrote a pretty good check to help USGS, and the university continues to push forward, getting new grad students and other things. And a lot has changed. A lot of new sensors in the basin, and a lot of overlapping information to confirm data. It's just to do the best we can to get this information out to the public. So we look forward to working with you guys this year and continuing on that. CBJ's got a few more irons in the fire. Just heard a week ago the Southeast Alaska Watershed Coalition announced that they have tentatively received $1.5 million grant for river studies that will be helpful in our building of the maps and the monitoring program. But it will also be looking at building natural revetments, log revetments. One of the places they're going to look at first is behind the field house. But part of the idea with log revetments is not only are you working on fish habitat, but you're slowing down the river instead of speeding it up. A lot of what we did over the last year is we rebuilt old riverbanks that were natural with new riverbanks that are all rock. And in that process, you speed up the river. So the work that the Southeast Watershed Coalition does will be quite meaningful. The Army Corps of Engineers is rebuilding those flood inundation maps. Due to the river's significant nature of change, the flooding areas will change, and we need to know the correct engineering for what size rock to put down, how to do a log revetment that's going to hold up, all kinds of different things. So the Corps is working on those maps and has some other things going as well. CBJ is working with the Corps and NRCS both on long-range studies of feasibility on the river. You know, you heard old city manager Rory Watt last year talking about, we'll build a siphon, we'll build a drain hole, we'll build, you know, all these theoretical ideas. And we're actually going to try and run them down. We're going to say, okay, how do you make the corridor carry more water, or can you drain the basin some other way? And the NRCS has said, hey, there's a machine that can drill a borehole to that basin in 8 days of a certain diameter, but nobody's done the feasibility of what diameter do you really need? Can you make a meaningful difference? And does a cost-benefit analysis even pencil? So there's a lot of different things they're going to be looking at, from dikes and drainage along the riverbank to floodways and diversions down the lower river to boreholes and other things. But they're going to do their best to try and define the problem and come up with some meaningful solutions that we can then look at cost-benefit analysis for and decide if we want to move forward with those as a community. Both the Corps study and the NRCS study are kind of free on the front end, a couple $100,000 each, and then they'll come back to the city with some ideas of proposals, and they'll want the city to take active ownership in those. These could be $5 to $10 million projects or more, and they can take as long as a decade to even come to fruition. So CBJ is working through the process right now by not spending a tremendous amount of money, but trying to find all the information that we can. And as those recommendations from the Corps and NRCS come out, we'll be coming back to the public through the Public Works Committee, and we'll be discussing those options with the public, and as a community decide what's meaningful and how to spend our time and money. So we look forward to talking with everybody, and we're going to take some seats now and be glad to answer all kinds of questions.
Yeah, I'm gonna turn that off and also turn the lights up. There we go, Glory's got it going. Yeah, maybe a little down.
Max and an off.
Try forward.
Are you talking about drainage for storm drains?
Yeah, all the drainage.
Yeah, so the storm drains, a lot of it, we're looking at putting duct bills on the storm drains so that they can't backflow. One of the things that's important to recognize is I live on Meander Way, and the storm drain in front of my house is the very first storm drain that backfills, and the water comes up in my street. but by the time water touches any home in Meander Way, it's already actually over the riverbank, through people's yards. So water could come up on the streets without the duckbills. The duckbills will slow that process, but by the time it gets to a home, the storm drains are meaningless because it's coming over all the riverbanks at that point. So it would protect the streets, but it will never protect the homes on those streets.
Good job, everybody. I'm just curious if there's any other basins that ice dam could form that you're looking at in the future.
Unfortunately, yes. There is one other basin if you get on Google Earth and you fly up the glacier a little farther on the left-hand side, so what would be the west side. There's a basin that looks relatively similar, and that's actually related to a project that we're trying to get funding for right now, which is looking more broadly across larger parts of Alaska. Now, there are now pretty good maps of like ice thickness for ice fields around Alaska, and so you could start to look at where these types of over-deepened basins might form when you have tributary glaciers coming in that can recede back. So yes to the Mendenhall, but again, we don't really have a good sense right now until we look at it more what the volume might be. And again, it's important to understand these kinds of outburst floods occur all over Alaska all the time. A lot of them occur in places where there aren't people, and a lot of them also occur in places like the Kenai River, where it's a very large river, and so the volume of water that you could store in the basin isn't going to make a meaningful difference downstream because it's just not large enough. I mean, a lot of people don't know there's a similar type of outburst flood from Lemon Creek Glacier, but the lakes are very small, and so when it floods, you wouldn't really notice because the volume just isn't there to create a downstream flood hazard.
On another note, like that, Mendenhall actually had an outburst flood in 2009 from Suicide Basin that was so small that no one really even noticed. So yeah, they happen all the time, all over.
Why does an outburst flood happen? Like, why isn't the water released slowly over time? And then also, why have there been more outburst floods in the recent years? What's causing that?
So a couple questions there. So the first question in terms of the timing of it, basically when there was a tributary glacier coming down and joining Mendenhall, the whole thing was full of ice. There was nowhere for water to be stored. When that glacier pulled back out and started to, the residual ice that was left over started to melt, then there's volume. And so when the original large outburst flood in 2011, there was still ice cover over the whole basin. And so it filled up and people didn't really notice, right? You just look out there and it's like, oh, look, there's ice out there. And then one day in July, the river started coming up and up and up, and we sort of, all the three of us jumped in a helicopter and it's like, oh, let's go find out where this is coming from. And we went up there and sure enough, you could see that it had drained down. In terms of the way that it drains, basically the idea is that the hydrostatic pressure of the water filling the basin will actually float the main glacier, and the water will start to flow out underneath it. And as it flows out underneath it, the friction basically heats the drainage tube under the glacier increases in size the more water that's running through it. So you imagine like if you're draining your bathtub and you pull the plug, and as it drains, the drain hole gets bigger and bigger. So it starts off very slowly and then it comes kind of shooting up, like Jamie has mentioned, this very pronounced flood wave that's characteristic of outburst floods. And again, like I said before, they're kind of decadal time scales, so we expect this to be with us for some number of decades looking forward, and that's kind of what we're trying to do a better job quantifying.
And you can never be sure if ice is going to block that hole either. So that's why sometimes we don't get a full drainage, right?
Traditionally, we've always had these outbursts, it seems like during a warm, sunny stretch, right? Has the perfect storm been discussed for maybe we've had a couple of atmospheric rivers and the river's already high and then we have an outburst like that?
After the first year of flooding, Ed actually did models. He took a fall flood and he took the outburst flood from 2011 and he overlaid the two, and we came up with models into the 30,000+ feet range. And that's what spurred us to reach out to Army Corps of Engineers to create the first set of theoretical maps. Last year we turned theory into practice, unfortunately, but that's what developed that model. And we'll go up beyond that this year to 17 feet with the new maps, so that we've looked at escalating situations.
Yeah, and I mean, even last summer, we had a really big rainstorm, probably 5 days after. And so, yeah, roughly a week after. And so I just took, with that storm, when you looked at it next to the outburst flood, looked very small, right? Because the rise and discharge was so small. But I took it and sort of put it back on top, and like they had been sort of started at the same time. And it, you know, it brought the crust up another couple thousand CFS, so it would have been even a much worse flood. So it is a really good point that that is something out there that could have a real sort of synergistic effect in terms of the volume of the flood.
And I believe 2014 was also similar. We were about 2 days late with the rain event on that one. But if that rain event had started 2+ days earlier, we would have had a double event then. So it'll happen eventually.
I just can't figure out, last summer did not seem like a particularly warm summer. And so I'm really mystified as to why did the flood not happen until August? Because I don't think it's ever been that late, has it, for the first event?
Yeah.
And so what's causing it to not drain, you know, to wait to drain like that?
Really good question. And that's that's exactly what we're trying to, like, what's that blocking mechanism? And then also the efficiency, how fast that water can get from the basin to Mendenhall Lake. And so that is a lot of the unknowns. I was saying, like, what's that triggering? What causes the trigger to have it start? Sometimes we've seen in the past where a heavy rain event would have them start, where you had a heavy rain event, then the next day you have an outburst. We've seen that on Lake No Lake on Taku River. So that's a really good question. That's something that we're really looking to try to get some answers to.
And a lot of our events have been July events, but we've seen them throughout the summer. But it is interesting that it took a lot longer for the basin to acquire that extra volume of water last year too. I think one of the things that we'll see with the Weather Service's new model, where they show that peak and they're already saying, hey, it could be 7,000 tomorrow. When we see them get to where they think it's gonna go over 12 feet and over 13 feet and over 14 feet, we'll already be sending out public messaging saying, hey, look, we're prepared for a big one if it goes full flush. It may stop partially down, but there's enough water in the basin now that we should all be paying attention, and the public information campaign will be very dynamic around that this year.
We've actually had a pretty large event in 2022 in October. So they're not confined to the summertime months. They can happen all the way into the fall time. So knowing some of those heavy rain events, and then if an outburst flood's going to happen on top of it, having those cameras up and the pressure transducers in the basin really helps the Weather Service understand what is going on. We don't have that equipment. We don't know what's going on in the basin. And so we have a heavy rain event. Is that all from rain? Is there some water coming from the basin? That's why having the USGS and having that equipment in there, letting us know what's going on, is so important, especially when we have these rain events. And this has happened in the summertime also.
And the River Forecast Center that's creating those hydrographs are really good about adding the rain on top of it. If rain did happen with it, they're really good about including the rainfall amount in their models.
And one other thing I'd point out, just a related issue, is that the filling actually has an endpoint, right? Because what happened last summer, and has happened several other times, is that the basin filled to the point where it just starts overtopping the dam. And so last summer, we could see that in imagery, that there was a river flowing on top of the glacier. And that was actually, in and of itself, starting to drain the basin, because the water that's flowing on top of the glacier incisors, right? It melts its way down into the ice. And so the basin was very slowly draining as this river was overtopping the dam. And mostly what we've seen, I think, is it's about within a week or so, once it starts overtopping, that it typically releases subglacially. And then obviously what happened last year is that it released and kept going. And in the past, you know, one thing that we had wrote a paper about this a few years back, and the person who wrote that, who was a postdoc here, hypothesized that maybe icebergs, when it started to drain, would clog the drainage hole and kind of choke off the drainage partway down, And for some reason that didn't happen last year. Whether it was that mechanism or something else, it was the first time that we were able to get that really low level and that really more like toward full volume discharge.
Another thing that was different last year is that there was a lot more floating ice instead of these like tabular ice. If you saw imagery going 10 years ago or even like 7 years ago, there was more tabular ice in there, where now it's all broken up. So now broken up, it gets further down, it can block or not block. There was another year where there was a double peak in 2018 where it went up and then it stopped, it came back down, then it went all the way back up afterwards. So it is very dynamic. There's a lot of different things going on within the basin on how it drains and does not want to drain.
And I will also say that the new models are built on the worst case scenario that we know. You know, for years it drained to this level. Last year it drained to this level. And this level is what the model is. But that doesn't mean it couldn't drain to this level. It's still dynamic.
So I live along the river. Sorry, I know you guys like to talk. But I live along the river, and after the flood last year, I heard dump trucks upstream of me, dump trucks downstream, excavators across the river. A lot of rock was dumped in the river on me. So what does that mean for me? What do I make of that with the next flood? What's the velocity going to look like? Well, how high is the water going to get? You know, what's the erosion going to look like? What can you guys do there?
So that's one of the reasons that we're definitely needing new maps. We took LiDAR in 2013. We took LiDAR right after the flood this year. And we took LiDAR after all the rock work was completed this winter when the river was at its lowest level. That LiDAR will go into new map work with cross sections that will be a part of the Yellow Jackets program. USGS will play a part of that, and several other agencies as well. That will build new flood models, and even the Southeast Watershed Coalition's work will lead towards those new flood models. Those new flood models will tell you velocity. They'll tell you how large a rock you need to cap your bank correctly. And so that's one of the reasons we're really pushing forward to have that done. We should know in early August if that funding came through, and we should hope to see those by next year if we're lucky. Go ahead.
Yeah, as someone pointed out, there's complicating factors like just because it overtops and that's sort of a new high level doesn't mean that the volume isn't getting larger because of the calving and all that other stuff. So can't get too comfy with the height maxing out, right?
Yeah, I mean, but we can also, because we're mapping with the drone, we can actually capture any added volume to it. And so in terms of like expansion outward, so we can quantify the changes in that regard. What we can't figure out is, I mean, I would say Tom's right that we don't know that we've seen the bottom, but I think we all agree like we're pretty close to the bottom just because of the way the topography is in there. It can't go a lot lower, and I think we sort of talked about this and figured like we could maybe add 10%, you know, there might be 10% more in there, but we've got to be just pretty close to the bottom there. And Jamie and I had some ideas about like dropping lead lines out of a helicopter and just trying to get a few points on the bottom, because that's the thing. It's like, and then someone said, oh, put a submersible, but it's like an iceberg nightmare in there, so you can't really drive a submersible around in there. But that is another data point that we're hoping to get, but I think we all agree that there's not too much down there. And really the other complication is the drainage conduit itself, we just can't see it, right? Because it gets covered in ice every year. And so we don't even know the elevation of the drainage conduit. We know about where it is, but we don't know exactly where it is, and we don't know what elevation it's at. So there are a lot of unknowns, and I think as Jamie's photo showed you, it's a pretty challenging place to work, for sure.
And even with the challenge of the ice melting and new calving ice being added in, so with less ice and less ice, you have more water at the same level. I mean, that's a whole nother equation that they're working to model, and Jason's done some great work on that. But it's a big piece of the picture.
With all the work that's been done on the river over this year, with all the work that has been done all along the river, and we live right on the river, if these new maps and scenarios come up and it goes up above, you figure it might go up above 15 feet or more, will all the riverbank property owners be able to go out and put more riverbank protection up to force, you know.
There's a multiple permit process, obviously, to do this kind of work. This year it was sped through due to an emergency in the state disaster declaration, which led to waivers for a 30-day period. But there will always be a permitting process to do roof work on the riverbank, and that people always have the ability to improve their riverbank. And that could include elevations should they choose. That's just part of a permitting process.
Okay, so if those, we lost some of our property that, because we're right next door to the city, which you know. So we have to have that reappraised to see where our property lines are, because it went down the river, our marker. So do we have to wait until we get that reappraised if we want to do permitting to do further work? Or if something comes up that's more urgent, can we do the permitting first and get the work done? Or?
I think you're going to find that if there's another disaster and we're seeing significant erosion and we can get another disaster process initiated to expedite the work, we would do that. But in general, we're going to want people to go through the engineering process, because putting 1.5 miles of gravel along the riverbank, the riverbank sloughed to the bottom of the river came up, and then people built their riverbanks back. CBJ said clearly in our statements, no recapture of riverbank, and yet some people chose to. And so that's part of the DNR permitting process. We don't control that, because that's in the watershed, that's not CBJ land. So, but we're concerned with people adding back in. And so that's a big part of the engineering process, is a no-rise certificate, which means that as you add back in, you're not pinching the river and making it worse for the people upstream. So there's a reason for the permitting process to be followed, and we'll do what we have to in an emergency, but ideally we have the engineering to do it the right way, which we don't currently. We follow the permitting process, and we shoot for zero rise.
But then at the same point, the river is, what, 2 to 3 times wider than it was on August 5th? So if there was
In places.
Yeah, right. But
And in places, those places got rebuilt right back to the same place. And that added a tremendous amount of material to the bottom of the river. Built the bank right back in.
Sandbars. We've never had a sandbar in the property before.
Yeah.
But, okay, thank you.
Yeah, and that's why it's just so important for us to move forward with new maps and get new engineering so that we can do the right thing for not just 1 or 2 homeowners, but for all the homeowners along the river, including the areas that flood that don't even live on the river.
Aren't you talking about the hydraulic analysis that you're required to have for the permit? You know, for permits, that was the hydraulic analysis that you required to do supposedly, because otherwise you'd hurt damage for FEMA, for the city or something, which, you know, didn't make a lot of sense to me when we had to do it, because when the Corps came, NRCS came through and looked at 29 houses on Meander Way and said if we rocked the heck out of it, far more than the 29 houses that now have rocked, it would raise the river approximately 3 inches, maybe. So each property there would raise, you know, 1/30 of the 3 inches. And so we had to spend $10,000, $12,000 for a study of that, which, you know, is really kind of ridiculous when you consider that the river is going up 17 feet over the top of every other amount that we normally think. Why require this? The city, you required it, the city required that hydraulic analysis. You know, you need to drop that.
There's 5 permits. The DNR permit, which is within the waterway, the Army Corps of Engineers permit, which is within the waterway, the fisheries permit, which is within the waterway, and the CBJ permit, which is the flat land on the top of your property and the street in front of your house. Some of those studies are required for other agencies and not CBJ permitting. It's a multitude of permits with a multitude of agencies.
Yeah, but that one just getting, that was.
We need the other agencies in the room to be able to answer that.
Yeah, you ought to drop that one and save some people some money. Because you know, it cost me $65,000 to do mine, and it didn't help a bit. Didn't do a penny.
I think we have a lot of people in the room who've lost a lot of money, and I think 65 is a low number for what I've heard from most people, and it's terrible. It's a terrible place for people to be, and I wish we could do better. It's amazing that flood insurance, FEMA money, it doesn't cover things you think it might cover. we're not really insured for the value of our loss, even with FEMA flood insurance. And most of us were above the floodway, weren't in a flood insured area, we're required to have flood insurance. And really, bank erosion isn't covered with flood insurance, and FEMA doesn't pay for bank erosion. Unless your house falls into a moving river. If the bank erodes and your house falls onto a gravel bar next winter, it's not covered. So it's tough. We all need to think about secondary insurance and how to make ourselves whole on the bad days. I can tell you that I now have FEMA flood insurance and I live a block off the river. My house flooded.
Hey, thanks a lot, guys, for your presentation. I was just curious of the group's thoughts or commentary on ground penetrating radar from the basin to the toe, and then also I had thought about some like oceanic mapping tools. I don't know, like submersible sonar or something where you could like do that underwater to see how the ice melt or the plug goes out or something like that. So anyway, I was just looking for commentary. Thanks for the presentation.
Well, with the submersible idea, we thought about it last year, like trying to get a better idea of what the bottom was by putting, like we reached out to NOAA, Corps, and even NASA and such, and pretty much it's just too hazardous. There's just too much ice to get something underneath there, sending something down there, and how much it would cost. And I think the best way for us to try to get is the sled line, to at least a starting point. But these guys will talk to you about the ground penetrating, ice penetrating radar that they thought about doing before.
Yeah, it's an elusive number, Andy. That one is we would really like to. I was trying to put a campaign together for this spring because we had we need cold snow, cold snow spring because of attenuation of the radar, but it needs to be done. And the glacier is such a way now that just simply moving on it is easier to pull off a survey. I know that there's some folks at the University of Fairbanks that have looked at doing some ground penetrating radar. I know it's out there. It's time intensive and expensive. There hasn't been a good radar survey, and it needs to be done. There's no question. I mean, really, from the basin all the way down. So, yeah.
We actually are going to test a helicopter mounted radar later this summer. That's Gabe Walken, who works for the state USGS. He's going to bring that down, and so we're going to try to do some mapping, basically the portion of the glacier from the basin downward, and then we're looking for funding next year to actually do the entire glacier with the radar. So keep you posted on that.
Thank you for your presentation. I have a question. As the river in our area has changed, the path of the river has changed drastically after this event. Are there any places that the city should step in and address their riverbank, maybe by Mendenhall River School, just past the Giroux's house, in order to be a good neighbor and potentially preserve some of the efforts that all of the homeowners have put forth to secure their property?
So CBJ has done bank stabilization projects on CBJ land, and we have done bank stabilization projects on CBJ land in between private homeowners. We know that if a revetment starts and stops, the revetment becomes weak. We know that if we're on the upstream end of your revetment and you build a revetment and we don't have a revetment, it can get in behind your revetment and cause problems. The downstream end of a revetment's a little bit different. That it doesn't have quite the same erosion, and so if we leave parkland open at the bottom of somebody else's revetment and parkland continues to fail, parkland continues to fail. But if a neighbor does a project, the end of River Court, both property owners did the project, we do the middle to honor their work and to make it stable and whole. We've done that in other places as well. At the Mendenhall wastewater treatment plant and the 3 homes above that. We did stitch work on CBJ land, CBJ land, private land, to work with those homeowners to ensure that those areas would maintain stability. There have been homeowners that have asked in other areas. That goes to the lands committee, and they work through that and make decisions as to where CBJ will spend time and money, as well as what liability CBJ will accept. Because in certain circumstances, it adds a lot of liability to the community in perpetuity, forever. If we did grants like we were looked at on Meander Way years ago, those grants would have cost the city millions of dollars. And then when the banks failed again, the city would be the one that was on the hook to fix those dollars. We could be having this conversation about avalanches or landslide zones, but it's hard to rob Peter to pay Paul when we all have a tremendous amount of hazard zones in our community. So it's difficult for the city to decide where to spend money to make people whole when we didn't choose to buy riverfront property.
So you don't fix it?
There are certain things that we will be a partner to fix, and there are certain things we will not. But I don't make those decisions. It always goes to the city manager level and through the public works committee. And those have come up on Meander Way and in other places, and I've worked with those homeowners to get them decisions from the engineers. And if you have projects you want looked at, we can work through that. And I know we've talked about the Drew's property. I know that Parks has no desire to harden the banks below your property, because as soon as I touch one tree and the next tree becomes an issue, I created the issue. If I cut a tree in the river and that tree floats downstream and causes a new log jam somewhere else, I created the issue. CBJ doesn't own anything below high water mark. That's DNR land, and that is personal land on your property.
So would DNR have to go to the CBJ to, like the trees that they took down because they deemed them possibly hazardous to fall on our property? They're 110, 120 foot tall trees, healthy spruce trees. Off to the right of us, we have, it looks like a logging yard. I'm sure you've seen it. And then some trees are coming down or laying in the river that they say they're not going to move. We're not going to pay to have them moved.
Right.
It's an eyesore, but I'm more concerned about the property, the water property down from us. If we do get another major event, it's going to keep eroding the city borough's property back up into the schools, back up into different areas, and that's probably what you have this working on, those areas.
When the flood happened, your home is a unique situation. You got to see a lot of it in person. The area below you on Marion Drive, those people had a significant shift in river. They went through DNR. They got permission to put heavy equipment within the river during a salmon run. Good luck with that if we tried to do it again. And they moved the river. They moved log jams. They dug the channel out. They changed the course of the river. What you need to recognize is those trees that are falling into the river are becoming the next bank stability project. They're actually starting to protect those banks. And when enough trees fall and enough dirt sloughs into those trees, they will become the new riverbank. But right now, if we go in there and cut every tree out, and it's another gravel riverbank, the next flood, it's just going to do the road 3 times as fast. So those trees are actually natural revetments, which are spawning habitat and slow the river down.
I understood that there's some areas where it's wide open still. That
CBJ is choosing to deal with it on a case-by-case situation, and if you email us, I'm glad to look at it and send you to engineering, and we can do what we can.
and thank you also for the presentation tonight.
You're all very welcome.
Very informational.
So what's going to happen with all the debris that's across from our house on Marion Drive? That we've been talking about here. It's just, it's a disaster. It looks like someone dropped a nuclear bomb over there, and the city has done nothing. Zero.
I don't think that's true, sir.
Well, the Rubicon people came, but the stuff was still there. They just stacked it up on the bank.
So the river was low. We got up there on foot. I worked with Team Rubicon that I brought in, and I spent days up there cleaning the banks, and I put it in piles so that when the river comes up, I can get to it with a jet boat, and I can haul it out. A lot of that debris above the high water line, back in the trees, it's never going to come out of there. There's 2 houses. There's a house
I
in
think
Forest.
that's right by my house. It's hot.
Yeah.
You know?
It's parkland.
You know, I lived it, just like everybody else here lived it, you know, and our bank, we used to be able to walk down right onto a gravel bar. And it just reversed what you were saying a few minutes ago. Now it's 12 to 15 feet deep there. But it didn't slough off and build up the bottom. It made a big ditch there from the trees that fell from CBJ property up by Giroux's that blocked the far side of the river, diverted it to our side. You know, so, I mean, and I know it's not your fault, but it's just maddening to, you know, to sit here and, I mean, to look out from our house and see what we have to look at.
The sad reality is a healthy river moves, and that's why it's called Meander Way. I live on Meander Way. My house flooded. I bought a house on a river that says Meander Way. Well, the river moves. That's why it's called Meander Way. The banks are going to continue to fail. With glacier rebound and river incision, they're always going to fail regardless of glacier outburst floods. We just have accelerated the process. And CBJ can't handle managing Mother Nature as much as we'd like to.
All right, well, maybe we'll stop there.
Sorry.
And no, it's all like, it's all good. I mean, and really what we are just hoping is that we provide you with the best information that we have. I will mention that this has been recorded. It's actually being streamed live right now on YouTube. If you go to the UAS YouTube page, if you want to relive any part of this presentation, or you know someone who missed this presentation that might enjoy it, you can go to the UAS YouTube page. There's a section that says live, and if you click on that, this will be posted there, and you could replay that. I would really encourage people to look at that monitoring page that we have this summer. I think any of us, I can speak for all of us to say, if you have questions, feel free to email us anytime. We're happy to talk with you about what we're doing, what we know, what we don't know, because I know people have a lot of questions, and so hopefully, you know, we're just trying to find the best ways to get information out to people. And I think Eran's point is probably one of the most important points, is that the forecast that you're going to see this summer is going to be a worst case scenario forecast in some ways. And so you have to keep that in mind, that it might not happen, and it doesn't mean that we didn't know the volume. We know the volume well. It just means that it didn't all come out. And that's kind of the best case scenario within the worst case scenario. So anyway, we can all hope for that. Thank you again for coming, and please do, keep up with everything on the monitoring page.
So the monitoring page will have a link to this recording. So just go to the monitoring page. You can get everything about the forecast and information within the basin. Thanks for...
Monitoring page is weather.gov/Juneau/Suicide Basin.
Screenshot.